Alright, here's the next lesson, and just before we start, let me talk about the previous set of problems that I gave you. With these problems, you had one polynomial adding or subtracting to another polynomial, and it gave you a result. Now, I'm not going to solve the problems and show you the answers. What I'm going to show you how to do is to solve and find out for yourself whether or not you got the correct answer. So to figure out if you have the correct answer, take your answer, the result that you get at the end of it, and subtract either q of x, in other words, the second polynomial, or you can simply subtract the first polynomial. That is, if you did an addition. If you did something like this, where you subtract like that, then you can figure out if you got the correct answer by simply taking the result and adding q of x. And you can also get it, well, yeah, just add q of x. And you should get p of x. If you get that, then that means you got the right answer. If you didn't, then you didn't have the right answer. You should work it over. Similarly, for this one, the answer you should get here should be p of x, that polynomial, and the answer you should get here is q of x. All right, so if you didn't get this result or this result after you subtract from your answer, or when you take your answer and you add the second polynomial, if you're doing a subtraction and you didn't get this, then you didn't have the right answer. So you should go back and try it again. Okay, so as I said, what we're going to do now is we're going to look at the multiplication and division of polynomials. So multiplication and division of polynomials. All right, so put that in green, drift it down a little bit. Let's start by looking at the multiplication first, because this is going to be the easiest. Multiplication. So multiplication. And let's give a small definition or small statement about what you're doing when you're doing multiplication. Take this, put this over here, and we can say when multiplying two polynomials, we apply the distributive law and multiply each term of the first polynomial to every term of the second polynomial. All right. Now, I'm not going to put this in a general form because it's going to be too cumbersome. So I'm just going to provide an example of what I'm talking about. So the first example is a very simple one. Let's say I have to expand and simplify. And we're looking at 3x into 2x plus 5. So again, we're using the distributive law. So we're taking this and multiplying it here, and we're taking this and multiplying it here. In other words, we're going to be taking the 3x term and multiplying it by the 2x term. Then we're going to add the 3x term multiplied by the positive 5 term. All right, and when you simplify that, you're going to get 6x squared, because we just simply have 2 x's, and we're also going to get 15x, right? So we multiply numbers by numbers, and we just count how many of the letters that we have. So we see in the x variable, here is 1x variable, 1x variable, so we have 2x variables, 1x variable here, and that's the answer. All right, let's go and do another one, a little bit more challenging now. Put this. So we're going to expand and simplify. We're going to expand and simplify x minus 3 into x minus 2. All right. x minus 3 into x minus 2, first off, we're going to use again the distributive law. So we're going to take this entire thing here and multiply it by the first term and then multiply it by the second term. So you'll get something looking like this. You'll have the first term in the second polynomial. You have the first term here multiplied by this x minus 3, adding to the second term, which is the negative 2. So negative 2 into x minus 3. Then we expand and we again use the distributive law. So we're taking the x and multiplying it here, we're taking the x and multiplying it here, we're taking the negative 2 and multiplying it here, and then the negative 2 and multiplying it here. So we're going to end up with something that looks like this. We're going to have x multiplying with x term plus, we're going to have the x multiplying with the negative 3. Then we're going to have the negative 2 multiplying with the x, and then we're going to have the negative 2 multiplying with negative 3. Then you simplify each one of those, and you get x by x, which is 2 x's multiplying together. So we have x squared. Then we have an addition of negative 3 by positive 1. So we get negative 3x. Again, remember the little faces, right? So plus, plus, if you have two of a plus value by a plus value, you're going to get a positive value. If you have a negative value by a negative value, you're going to get a positive value. And if you have a positive multiplied by a negative, you're going to get a negative. And if you have a negative times a positive, you're going to have a negative as well. All right? So just remember that, and all the multiplications that you have would be easier for you to do. There, right? We just continue the solution, so plus, and then we have negative 2 by x, which is going to be negative 2x, and then we have negative 2 by negative 2, which is going to be positive 6, and then we simplify all of these signs inside of here. So this here we simplify, this here we simplify, and this here we simplify, and we'll be able to get our answer at the end, which is x squared minus 3x minus 2x plus 6. And with that, we simplify even further by combining these two terms together. So it has negative 3x's here and negative 2x's here. So we're going to get x squared minus 5x plus 6. All right, and that's the answer for that. Now, I take my time and I did this. You don't have to. You can skip a few of these parts, a lot of these parts, I should say. So you would go from, normally during the solution, you'd go from this white piece here to this, and then to this, and that's it. This orange part here, most of the time you don't use that. All right. Next, let's do another example again. Something a little bit more complicated, about the most complicated you should expect with your examinations, and that is something like this. So x plus 2 into x squared minus x plus 4. Again, we're going to use distributive law, so you can stop and try and see if you can solve it. So we're going to take this entire thing here, then this, then this, then this. All right? So you're going to end up with something that looks like this. You're going to have x squared multiplied by x plus 2, adding to negative x multiplied by x plus 2, adding to 4 multiplied by x plus 2. We simplify each of the terms in the bracket. So we have here, let me just put the arrows. So here by that, here by that, then we have here by this, here by this. Again, I'm doing this slowly so you can see all the terms that I'm multiplying by each other. All right, so we have x squared into x, and then we have x squared into 2, then we have negative x into x, then we have negative x into 2, then we have, let me go on the next line. Actually, you know what? I can just probably move this around a little bit. Let me just see if I can move this around a little bit. Yeah, all right. Then we have 4 by x plus 4 by 2. All right, simplify and solve each of these, and we get x to the third power because we have 1x over, sorry, 2x's over here and 1x here. So that means when we multiply them, we add the powers up. So 2 and 1 is 3. Then we have 2x squared. Negative and a negative is going to give me another negative, so negative x squared. Then we have negative 2x, and then we have 4x. Then we have 8. Resolve the signs that we have in front of each of these, which is this one here, which is this one here, and simplify. We're going to get the following answer. Let's see, we're going to get x to the third power plus 2x squared minus x squared minus 2x plus 4x plus 8. And that results in x to the third power plus x squared plus 2x plus 8. And that is the most difficult thing that you would get when it comes to multiplication of polynomials. All right, so let's move on now to division. So let me put this here. I just put sign here, here. We say division. All right. All right, now division is a little bit more challenging than the multiplication because you have a few more rules to follow. Let's give a small note here. To divide one polynomial by another, we use polynomial long division or synthetic division. And the result is the quotient and a possible remainder. Sometimes you may not get a remainder. All right. The polynomial long division, and I'm just going to highlight that for you to see over here. The polynomial long division is what you should learn. The synthetic division is what you should have in your toolbox. Meaning that this polynomial long division will work for all cases, while this synthetic division will work for certain cases. But it's much faster to use this in the cases that it works for rather than use the polynomial long division. I'm going to do both so you would see exactly where and when you would apply it. So let me just put a definition out here with respect to the name of certain terms or the name of certain parts of your problem. So usually when you have a problem for division, you would have some polynomial p of x divided by another polynomial d of x. And you would usually get a quotient q of x and some kind of remainder r of x. All right. And let me just put a name for each one of these so that you can have them. So this here is called a dividend. This here is called a divisor. This here is called a quotient. Or basically it's the result of p of x divided by d of x. And this here is called a remainder. Now, sometimes what you would see is that they write it in another form. What they do is they multiply both sides by d of x and they will end up with something like this. P of x is equal to d of x. Oopsie, this remainder at the end here is supposed to look something like this. Let me just put this back here. So this is a remainder. And the remainder is usually a fractional form, so you would see that this here is over d of x. Right. Okay. Right. So as with any fraction, you would have a remainder, and that remainder is supposed to be divided by the divisor. Good. Just like you have with fractions. So like if I had, let me just put this. So if I had like 5 divided by 2, I would get 1, which is the quotient, and then add that, I would have remainder 1 divided by 2. So notice how the dividend here, this is the divisor, this is the quotient, which is the result of taking 5 divided by 2. Oh, that's wrong. Oh my God, making lots of mistakes. This is 2, right? So 5 divided by 2 is 2, and then we have one remainder, 1 divided by 2. All right, so same thing here. And when we multiply everything by 2, in this case, when we multiply everything by 2, we'll get that 5 is equal to 2 into 2 plus 1. All right, and notice you get back the same 5 on the top. So similarly, in that kind of principle, you would have q times x plus the remainder of x. All right, so what I'm going to do now is I'm going to show you how to do the divisions so that you'd be able to solve any one of the division types that you're going to get. All right, first off, we have division by a monomial. Okay, division by a monomial. All right, this is just a fancy word for saying a single term. Right? It's a fancy word for saying a single term. It would usually have the form ax to the power of n, where n is greater than equal to 0. All right, let me give you an example of that monomial that they're talking about. Let's say, for example, we have something like 2x cubed plus 3x squared minus 5x minus 6, and we divide that by x plus 2. Sorry, not x plus 2. X, let's say 3x actually. Yeah, let's say 3x. We will get something like 2x cubed over 3x plus 3x squared over 3x minus 5x over 3x minus 6 over 3x. And then we just simplify. So 1x will cancel off here, leaving us with 2. 1x will cancel off here, leaving us with 1. 1x will cancel with 1x here. And we will get a result of 2x to the second power over 3 plus 3x. Oh, cancel these 3's as well. Forgot that one. So we'll get just simply x. And then we have a minus sign, minus 5 over 3. And then we're going to remain with 6 divided by 3x, which I should really cancel off and write as 2 over x. All right, so this is the division of this by this, and we get this here. Okay, now that is about as easy as it's going to get when it comes to division. Okay, that's about as easy as it's going to get when it comes to division. Usually, most of the time that you have to do a division, you have a division by something that is not a single term, not a monomial. All right, so let's say example of that would be 2, let's use the same numerator, plus 3x squared minus 5x minus 6, and then we're going to divide that by x plus 2. Now I'm going to solve this in 2 methods. I'm going to write different colors for each of the methods. The first one I'm going to do is I'm going to do polynomial long division. So let me just stick that here, and I'm going to say polynomial long division. Yeah, long. All right, so first off, we're going to set up the problem. We're going to put the dividend inside our long division sign. So I'm just going to put 2x to the third power plus 3x squared minus 5x minus 6. And then I'm going to put the divisor, which is x plus 2 on the outside here. Now, the goal of the long division is to simply match the first term. Right? We simply have to match the first term. So what I usually do is I usually put that first term like here, cube, and then I divide it by the highest order of the divisor, the highest order term of the divisor, which is the x. So in this case, x. Notice after I do the cancellations, I will get 2x to the second power. So what I will do is I'll put that 2x to the second power here. I will put a minus sign, open a bracket, and what I'm doing is I'm taking this 2x and I'm multiplying it here, and I'm taking this 2x and I'm multiplying it here. When I multiply it, I will get 2x to the third power, and then I will get plus 4x to the second power. So this by this. I simplify by subtracting that polynomial from the other polynomial. So I take this polynomial here and I subtract this polynomial. Notice that this here will subtract with this. I will get 0. And then this here will subtract. Notice a subtraction and an addition, that will give you a subtraction when they multiply it out. So a subtraction of 4x from the 3x squared, 4x squared from the 3x squared will give me a minus x squared. Then I'm going to bring down the rest of terms here, which is the negative 5x, and I'm going to also bring down the negative 6. Next, what I'm going to do is I'm going to do the exact same process. I'm going to take that first term out in the front, which is this one here, minus x squared, and I'm going to try and divide it by this highest order term in the divisor, which is x. X cancels here, leaves 1, and I will remain at minus x. Minus x. Alright? So now that I have my minus x up in front of here, I would just simply put minus x on top here. You know what? Since I'm using yellow for most of the other parts of it, I will use yellow here. So 2x squared. Now that I'm using pink, I will stick with pink throughout this part. So I will take the minus x now here and multiply it with the x, and I will take the minus x and also multiply it with this positive 2, and I will be able to get minus open bracket, and I will get minus x squared, and then I will get minus 2x, close the bracket. And now I simply take this on top here and I added the resolution of these two terms, these two negative signs here, is going to be a positive. So I'm going to take this and add this, and I'm also going to get 0. And then this is negative, so this is negative 1 by negative 2, so that's going to give me a positive 2. So negative 5 plus 2 is going to give me negative 3x minus 6. And then I work on the last part, all right? I work on the last part, so I bring down this 6 here to get that negative 6. Then I work on the last part, so I am working on the negative 3x, and I'm dividing it by the x again. I'm getting negative 3. So I'm going to use negative 3 out in front here. Negative 3. I'm going to take that negative 3. I'm going to multiply it again by this, and I'm also going to multiply it again by that. All right? And that's going to give me negative open bracket. Then I multiply it, so negative 3 by x will give me negative 3x. Then negative 3 by positive 2, that's going to give me negative 6. All right? And yeah. Simplifying that, I'm going to get that this add to this is going to give me 0. And then this add to this is also going to give me 0. And that is the end of it. So I am saying that 2x cubed plus 3x squared minus 5x minus 6 divided by x plus 2 is going to be equivalent to whatever is on the top there, which is 2x squared minus x minus 3. Another way we can write this is we can say that 2x cubed plus 3x squared minus 5x minus 6 is equivalent to x plus 2 times 2x squared minus x minus 3. All right? Now, this is a very long and, quite frankly, it's a little bit tedious to get done. All right? Quite frankly, it's a little bit tedious to get done. And because of that, we have synthetic division, which is what I'm going to do now. Synthetic division. So with synthetic division now, we're only allowed to use this when the order of the polynomial, that is the divisor, is of degree 1. So in this case where I have 2x, let me write again, 2x to the third power plus 3x squared minus 5x minus 6 all over x plus 2. I am only allowed to use synthetic division in a situation where I have a divisor of the form ax plus b. This is the only situation in which I can use synthetic division. Otherwise, it doesn't work. All right? Now, first thing that you need to do for synthetic division is you need to solve this equal to 0. So x plus 2 equal to 0 is going to give me x equal to minus 2. So first, draw a line here, I put the minus 2 out in front. Then I'm going to take each constant out from the polynomial on the top, which is the dividend. I'm going to take each of the constant terms. So I'm going to write each one of them in a different color. Let's say 2, and then we have 3, and then we have -5, and then we have -6. Right? Once I have that, I'm going to solve by taking the 2, bringing it all the way down here, 2. Then I'm going to take this 2, multiply by this, which is going to give me -4. I'm going to put that right underneath here, -4. When I add these two values together, I am going to get -1. Then I'm going to do the exact same thing. I'm going to take this -1, multiply by this -2. I'm going to get a +2. Just going to put that in orange. I'm going to have a +2 here. I'm going to add both of them. I'm going to get -3. Now I'm going to take this -3, multiply by this -2. I am going to get +6. And I'm going to add both of them together. I'm going to get 0. All right. Now here's how you interpret this. We're going to have one less than the highest order that we have in the original dividend polynomial. So this dividend had a degree of 3, right? It has a degree of 3. What we're going to have now is a result that is of degree 2. And here's how the degree 2 starts. It's going to take 2 into x squared minus 1 into x, which we can just simply write as -x. And then we're going to have -3, which is just simply -3. And this here, this last one, is the remainder. That there is the remainder, so the remainder is 0. So that means that the result of this divided by this is equivalent to 2x squared minus x minus 3. That's the answer. And if you look back, you would see that that is the exact same answer that we got here previously. Right? So instead of doing all of this, we can just simply do this and that will work. But again, it only works when you have a divisor, sorry. It only works when you have a divisor that is of this form, ax plus b. All right. Let's see if we can do another problem. I'm going to do another problem and I'm going to use it with both long division and divisor again. Right. Sorry, synthetic division and long division. So let me give you another one. Let's say, for example, we're required to solve 3x to the 4th power minus 2x to the 2nd power plus 5x plus 4 all over x plus 2. Now I'm going to go a little bit faster here, but hopefully you'll keep up with my speaking the way so that you'll be able to follow along. Let's do the long division method, the polynomial long division method in white. So let me first write the divisor here. Then I'm going to write the dividend, which is 3x to the 4th power minus 2x to the 2nd power plus 5x plus 4. Now, the problem here is that I don't have all of the polynomial orders. In other words, it's not consistent. Let's see, x to the 4, x to the 2, x to the 1, x to the 0. I don't have an x to the 3. So to make my work easier, what I have to do is I have to include that inside of here. All right? So I have to include that inside of here, and I'm going to put that in yellow so that you can see that is added. So 0 plus 0x to the 3rd power. We're doing this so that you don't miss out on that x to the 3rd power and cause a problem when you're doing the subtractions. For example, once I multiply this by something, once I multiply this x plus 2 by something, I would get something x to the 4th and I will get something x to the 3rd. And I might mix it up and I might say, oh, well then this x to the 2nd minuses off for that x to the 3rd. That will be wrong. All right, so I usually add 0x to the 3rd. If it's missing or whatever is missing, I usually add 0x to whatever. And that way I can make sure everything lines up and I don't make errors. So let me go a little bit quickly now. So First thing I want to do, 3x to the fourth power divided by x, cancel it off. I'm going to get 3x to the third power. Okay, so that means 3x to the third power goes up here. When I multiply, I put this down. When I multiply, I'm going to get 3x to the fourth power, and I'm also going to get 6x to the third power. Simplify that, I will get 0 here, and I will get negative 6x to the third power here. Bring down the remaining 3 terms that I have, and I will get negative 2x to the second power plus 5x to the plus 4. Go on to the next one now. So I am looking at negative 6x to the third power. Divide that by x. I'm going to get negative 6x to the second. So I'm putting here negative 6x to the second. Minus 6x squared by the x is going to give me, open bracket, minus 6x to the third. And then we have minus 12x squared. Close that bracket off, simplify. So this here plus this is going to give me 0, and this here plus that is going to give me what is that, 10, positive 10x squared. Bring down the rest, which is this, and we will have positive 5x plus 4, and then we have 10, let me just put an x color, we have 10x to the second power divided by x, which is going to give us 10x. I'm going to put positive 10x here. Positive 10x by that is going to give me, let me put this over here, positive 10x by that is going to give me positive 10x squared, positive 20x. Work that out, that's going to give me 0. This is going to give me negative 15x, bring down the 4, positive 4, and then I have negative 15x divided by x. That will give me negative 15. And let me change one more time. So negative sign, open bracket. So I'll say in the negative 15 here. All right, negative 15 there. So negative 15 by this out in front here is going to give me negative 15x minus 30. And then this here results in 0. This here added gives me 34. All right, so this works out really quickly because now I will be able to say that 3x to the fourth power plus 0x squared, sorry, let me not put back in that, minus 2x second plus 5x plus 4 is equivalent to x plus 2 into 3x cubed minus 6x squared plus 10x minus 15. And let's do it again now with synthetic division. And I'm going to write this in a blue, a nice blue. Let's see. Let me just copy and paste this. So I'm copying this entire thing here, Control C. And then I'm going to paste this down here, Control V. I'm going to change the color of this to blue. And that's going to match there. All right, so first things first, we solve for x plus 2 equals 0. We're going to get x is equal to minus 2. All right, then we put the x, well, we put the minus 2 out in front, minus 2. Then what we do is we list the coefficients of each term. So we list this one, we list this one, we list this one, and we list this one. Now here's the thing. Because we're missing x to the third power, we're going to have to add in 0 to say that we have nothing with x to the third. If we don't do that, it's going to cause a problem with the solution as well. So we're going to have here, in the solution, we're going to have here 3, and then we're going to have to put in this 0 here because it's non-existent. That term is non-existent, or it is 0 actually. So negative 2, and then 5, and then 4. And again, we're going to follow the same process. We're going to bring down this 3, which is here. We're going to multiply this 3 and this 2, which is negative 6. We put that over here. We add these two terms together. We add these two, and we get negative 6. We do the same thing again. We're doing another multiplication, negative 6 by negative 2, that's positive 12. I'm going to put positive 12 here. I'm going to add these two, I'm going to get 10 over here. I'm going to take negative 2, multiply by 10, I'm going to get negative 20. Negative 20 here. I'm going to add these two together, and I'm going to get negative 15. Then I'm going to take 15 and multiply it by negative 2, I'm going to get 30. I'm going to add those two together, I'm going to get 34. And my result is, remember, 1 less than the highest power, which is x to the fourth. So I'm going to have 3x to the fourth minus 6x to the third plus 10x to the second minus 15, oopsie, not fourth, well, I make a mistake already, x to the third, one less than the highest degree, here, second, first, and then 15, and then the remainder will be 34. You know what I just realized? I just realized I put the error over here because I did not put in the remainder at the top bottom, which is the 34. Right? I did not deal with that 34 at the end. Let me just put this here. And the end of this, right? The end of this plus 34 is supposed to be here. Right? So this times this plus 34 is going to give me back this exact same thing here. All right, so let me come back here. So this is this, and the remainder 34. So I will have 3x to the third power minus 6x squared plus 10x minus 15 times the original x plus 2 would be equivalent to, plus the 34 would be equivalent to the original equation, which is 3x to the fourth minus 2x squared and then plus 5x plus 4. Right? So that is the result of every single one of them. So these are the challenging problems that you would have. And you can see that it's not going to work for long division if you have something that isn't of the form ax plus b by simply trying this problem out. You can try this one here. Let's say you have 2x to the third power plus 3x squared minus 5x plus 6 divided by x squared minus 1. In this situation, you have to use long division. So you should learn both methods just so you have both of them, right? Long division is the only way you can solve this. Well, you can solve it another way, but it's far too complex and annoying to get done rather than just simply using the polynomial long division, all right? You can try now some problems and verify the answers to your problems by just simply taking the result that you get, the remainder, plus this multiplied by the result that you get. If you get back this original one, or the original dividend, I should say, then your answer is correct. If you did not get back the original dividend, your answer is not correct. All right? So you can try the problems and check your answers. The reason I'm not giving you answers and I'm requiring you to check it yourself is so that you can get more familiar with moving around your terms in algebra. All right? If you move around your terms more and you play with it a little bit more often, you'd be able to learn it easier. All right? So try these questions and see if you can solve them and test and see if you get the correct answers for yourself. So 4x plus 7, let's say we have x minus 3 into x plus 4, then let's say we have 8x x squared plus 12x divided by 4. Let's put x here. Yeah, that's fine. Let's say fourth one. Let's say we have, maybe I should give you another multiplication one, plus 1 into x squared minus 2x plus 5. Let's see. Let's say number 5. Let's do another equation. 6x squared plus 11x minus 6 all over, let's say, x minus 1. This one you can use synthetic division on 6. Let's say 2x cubed plus 5x squared minus 3x plus 4 divided by x squared plus x minus 1. And then some, let's see, you know what, let me just give you something easier than 3x cubed minus 6x plus 7 all over x plus 2. Ooh, one more thing. When you're doing this division here, the answer that you have for the remainder will always have a lower order than this x to the second. All right, you can't have it higher. If it was higher, then you would get it in the whole part of it. All right, so notice that no matter what your answer is, like for example this one here, we will have x to the 0, which is this, as the remainder. All right, so when you solve this one, you would notice that you would get 1 power of x at the end. You know what, maybe I should just solve this and done, just so you can see what I'm talking about. Control C, and let's just add an next page right here, Control V, and I'll just do it really quick. I'm not going to say anything much. I'm just going to put down the solution for this. Well, I'll probably talk, but let's see, x squared minus 1, and then we put in here 2x cubed plus 3x squared minus 5x plus 6, and then on the top we're going to have 2x cubed divided by x squared is going to leave us with 2x, so we're going to put 2x here, minus open bracket 2x cubed, and then 2x by -1, negative 2x. Simplify that, we're going to get 0 here, this is add, so we're going to get plus 3x squared, and then add to that will be negative 3x plus 6, right? That's after I bring down, I use this, right? So -5, add this, and you get -3. This comes down by itself, it's adding with 0. This is here, and then we have, let's see what again. So we have 3x squared divided by x squared, which is just simply 3. Okay, so we just simply take positive 3 and multiply it. So we get positive 3x squared minus 3, and notice we get 0 here, but this here can't add with this, so we have negative 3x, and then we have positive 3, and then we have positive 6 coming down, and we can't go any further, right? So 2x to the third power plus 3x squared minus 5x plus 6 is equivalent to saying 2x plus 3 times x squared minus 1 plus the remainder, which is negative 3x plus 3 plus 6, which is working out to be 9. All right? Oopsie, plus 9. All right? So try and see if you can resolve this on your own first, and you should be able to get it well done.